Hello students, welcome back to my YouTube channel Civil Edu Next. Myself Maitri Dave, Assistant Professor at LJ Institute of Engineering and Technology. Today we are going to discuss about angular measurement. So let's start our lecture 4. But before that, let's discuss what we have learned in the previous lecture. So in previous lecture we have discussed the terminologies like forebearing and back bearing, as well as we have seen different examples related the computation of interior angles, right? And in today's lecture we are going to discuss about our first topic, which is of local attraction, and our second topic is examples related to local attraction. So without wasting much time, let's start our first topic, which is of local attraction. Now the first question that arises in our mind is, what is a local attraction, right? So basically local attraction is something that when the compass is set up around the iron or steel structures or under electric cables carrying high voltage current, then the magnetic needle of the compass will not point to the magnetic north, but it is deflected from its normal position. So this kind of situation which deviates the needle from the magnetic north, it means its original position, is known as the local attraction, because under the influence of magnetic substances the deviation of needle take place. That whole process is known as the local attraction, right? Now the bearings are measured from such station points are not correct. For that we have to identify which are the reasons that local attractions is present and how we can detect it and how we can remove it, right? So it is required to be corrected before plotting the traverse, right? Now let's understand the sources of local attraction. Basically there are two types of sources, in which the first one is the natural, which is naturally available as iron ores or the magnetic rocks available at that place. Or the second type is known as the artificial. It means different structures like steel structure, rails, iron pipes, electric lines, metallic chains, arrows, ranging rods and bunch of key can be a reason to act as a local attraction, right? So now let's understand what are the methods or the procedure to detect any local attraction. For that we can simply say in one equation or one line that the difference between the forebearing and back bearing should be 180, because it says there is no presence of local attraction if the difference is of 180, right? But if the difference is not 180, then it is sure that local attraction is present over that station, right? So after detecting the local attraction, it is very important to correct the local attraction. So for correction of local attraction, there are two methods. It means first is the using corrected angles, in which different steps one should follow. In which the first step is the interior angles are calculated from observed bearings. Then after angular check, it means the sum of the interior angle can be checked through the equation which says 2n minus 4 into 90 is equal to the sum of the angle, right, that you have calculated. Then if the check is not satisfied, total error is equally distributed and corrected angles are found. Then after using corrected angles, starting from unaffected line, bearing of all line can be corrected. So this is the method for corrected angles. But the second method for without using corrected angles, there are different steps are there, in which first one is the interior angles are not calculated. That is the difference between these two methods, right? Secondly, starting from the unaffected line, bearing of other affected line are corrected by finding the amount of correction at each station. And then all lines are affected by local attraction is there, then the line with minimum error is identified. And then forebearing and back bearing of this line is adjusted by distributing the error equally, right? So this is the method. And then starting from the adjusted line, forebearing and back bearing of other lines are corrected. So this is the steps followed when we talk about without using corrected angles, right? Okay, now let's move to the main topic, which is topic number 2, which is the example of local attraction, right? So in the example of local attraction, the data should be in such a way which says the following fore and back bearing are observed while running a closed traverse A, B, C, D, E, A. Find out which stations are affected by local attraction and calculate correct bearing and included angles. Also apply necessary checks. Here on this table, different lines are mentioned like line AB, BC, CD, DE and EA. Here 5 lines are there having their own forebearing and back bearing. But in example, it is clearly mentioned that which are the stations affected by local attraction. That is the indication that this sum is of local attraction, right? Again, they are saying correct the bearings and find the included angles and apply the necessary checks, right? So now we have 2 methods, but before that, first we have to find which stations are affected by local attraction, right? So here, difference between forebearing and back bearing should be of 180. It means there is no local attraction. But if it is not 180, it means local attraction is present. So here on this table, you can see the line, their forebearing, back bearing and difference is calculated. Here you can see line AB having the difference of 180, line BC having the difference of 181, CD 179 degree 30 minute, DE 179 degree, EA 177 degree 30 minute. Here only line AB having the difference of 180. It means I can say that station A and B are free from local attraction, right? While station D, C and E are affected by local attraction. That is the general conclusion we can take after this kind of calculation, right? Now, if we calculate this sum using first method, which says by calculating the included angle, you can see I am trying to plot the traverse as per given data, right? Here I have put all the 4 bearing values first according to the given table, right? Then after I am trying to plot the back bearing of all that stations so that you can see that traverse ABCD is mentioned now. Now after drawing the traverse, what we have to do? We have to check the calculation of interior angles. It means that is already known to you that you have to make a table, and in this table you have to do the summation of the angle, and for that different angle calculation can be computed as per the taking the difference of forebearing and back bearing of lines of that particular station. Here angle A can be calculated as back bearing of EA minus forebearing of AB, which gives the answer as 126 degree 30 minute as an interior angle. Likewise, angle B can be calculated as back bearing of AB minus forebearing of BC is equal to 110 degree. It means the interior angle. Again, as I said, this interior angle and exterior angle can be known only if you have drawn the traverse correctly, right? Likewise, angle C can be calculated as the back bearing of line BC minus forebearing of line CD, which gives the answer as 126 degree as an interior angle. Then the angle D, which is the exterior angle, when we do the forebearing of B minus back bearing of CD, which gives the answer of 289 degree, which is exterior. It means we have to do calculation of 360 minus 289 degree. It means the answer is 110 degree, which is the correct answer in terms of interior angle, right? And lastly, the angle D, which is back bearing of DE minus forebearing of EA, which is of 106 degree 30 minute, which is the interior angle, right? After doing this, you are simply go for the check, right? While you are go for the check, you are doing the sum of the interior angles, which is 540 degree over here, as the 5 lines are there, and you have again a equation for check, which is 2n minus 4 into 90, which gives the same value 540. It means there is no correction required. Above found values are corrected ones. So till now you have completed 2 steps, in which first one is you have identified which are the stations which are affected by the local attraction, and second you have identified the interior angles, right? Now we do the calculation for correct bearing using corrected interior angles, right? The first method. So for that, the traverse that we have drawn is something look like this, right? Now we know that station A and B are free from the local attraction. So for station A, I can say the back bearing of EA is correct, as well as the fore bearing of AB is also correct, as this is free from local attraction. That given value is correct, right? As well as for station B, the back bearing and fore bearing are also correct. But station C, D and E are affected by local attraction. It means the bearing of lines measured at these stations are not correct and it need to be corrected or found, right? So for station C, fore bearing of BC is 138 degree. As I said that it is correct at station B, right? So from this corrected value, now I am going to calculate the corrected back bearing of this line. Now you know the relation between fore bearing and back bearing. So if you have the value of fore bearing, you can calculate the value of back bearing. How? If it is lower than 180, you have to add it. If it is higher than 180, you have to minus it. Now you have the value of fore bearing of 138 degree. It means it is lower than 180. It means you are adding, so that your back bearing of line BC is equal to 180 degree plus 138, which is 318 degree, which is corrected, right? That you have found now. Now, once you know the back bearing value, now you can calculate the angle C. Now you can see in this traverse that angle C can be calculated as back bearing of BC minus fore bearing of CD. Now angle C is also known to you, that you have calculated in the interior angle calculation. Back bearing of BC that you have just find. Now you put all the value and you get the corrected fore bearing of line CD, right? So that is the method in which angle is used to identify the next correct line, right? So now for station D, the correct line that you have just find is the fore bearing of line CD. So from this you can find the back bearing of line CD. It means simply if you know the fore bearing, you can calculate the back bearing. Here the value of fore bearing is 192. It means it is higher than the 180. It means you are simply minusing it. So you get the value as 12 degree, which is the correct value of back bearing. Now you can see in this traverse at station D, you can identify angle B as fore bearing of DE minus back bearing of CD, which is the exterior angle, right? So you can identify fore bearing of line DE by putting all the values which is of 301 degree, right? So that is the correct answer. So this is the way for station D. Now for station E, you have identified the fore bearing of DE. Now you can calculate the back bearing using the equation where 301 is higher than 180. So simply minus it. So you get the 121 degree. Now you can see in this traverse that you want angle E, which is back bearing of DE minus fore bearing of EA. So putting all the values, you get the correct fore bearing of EA, which is of 14 degree 30 minutes, right? So this is the way from which you can calculate the all the lines get corrected, right? Now the same thing if I want to calculate by using second method, it means without calculating included angles, we can calculate the corrected bearings, right? So here the traverse is same, all the data is same, the concept is again same for first few steps, like that station A and B are free from local attraction, that we know. So for station A all the data is correct, as well as for station B all the data is correct. But for station C, as it is affected Only fore bearing is corrected, but now we know we can calculate the back bearing by using the correlation between fore bearing and back bearing, which is of 318 degree. But in given data, we have some different value. It is not 318 degree. So we can identify error at C. So I can calculate error at C is equal to back bearing of BC line given in example minus correct back bearing that we have calculated. So here I get the error as 1 degree. Now whatever the error I get, I simply add or minus it to the next line, right? So here error is 1 degree, so correction is minus 1 degree. So correction of fore bearing of line CD is equal to fore bearing of CD given in example plus correction. It means it is 192 degree. That is the correct answer, right? So here there is no need to calculate the interior angles. What you have to do, simply from fore bearing you have to calculate the back bearing. Once you calculate the back bearing, just compare it with the given data in example. Then you get the error. Once you get the error, if it is positive for correction, do the negative, right? And whatever the correction you have identified, please put it to the next line or the coming line regarding that station. By doing these steps, you can identify or you can calculate the corrected bearing for all the lines. So this is for station C. Now let's do the same procedure for station D. Now you have corrected fore bearing, you know the calculation for back bearing, which gives you the answer as 12 degree. And now you want to calculate the error at D, which is back bearing of CD given in example minus correct back bearing of CD, which is 1 degree 30 minutes. Now correction is minus 1 degree 30 minutes, and that I should provide to the fore bearing of DE line. So which gives me the answer as 301 degree, which is the correct answer, right, for station D. Likewise, we do the procedure for station E. Here you can see the fore bearing that we get just, which is of 301 degree. Then we can get the back bearing by simply minusing it from the 180, which is 121 degree, right? Now, if we want to find the error at E, it is back bearing of DE given in example minus correct back bearing of DE, right? So we get the answer as 2 degree 30 minutes. It means the correction is minus 2 degree 30 minutes. Now, once we get the correction at E, we simply do the corrected fore bearing of line EA. It is fore bearing of EA given in example plus correction, which is of 14 degree 30 minutes. Now we have calculated all the stations get corrected by doing this kind of calculation, right? Now I can say that any of two methods I use, we can correct the bearing which are affected by local attraction, right? Now you can see one table over here in which fore bearing and back bearing value are mentioned. Now the red market value are the values that are corrected by using these two methods. After providing correction, you can see the difference of fore bearing and back bearing at every line is getting 180. It means the local attraction is removed. So this is this last step for both the methods, which provide justification that your calculations are correct or not. So it is again a very important, right? So this is all about the local attraction sums with two methods, right? So when you see in the exam this kind of examples, first you have to identify that this sum is of local attraction or not by identifying the word local attraction in the example, right? At the same time, if it is asked specifically to use which method, if it is not asked, you can go with the whichever method you like or you find easy, right? So this is all about the local attraction. So in today's lecture, we have discussed what is local attraction, what are the sources, how to detect it, how to correct it, and how to do calculation for local attraction. I hope you learn all these in detail in today's lecture. See you soon in the next lecture. Thank you for watching. Don't forget to like, share and subscribe my YouTube channel, Civil LJIET Next.